collision and center of mass. Center of mass. Center of mass of system is the point associated with the system which have same relations as the accelerations of point mass of same that means that means of same mass as that of the system would have under the applications of same external force. Center of mass of system of discrete particles x, y, z, and this point indications m1, x1, y1, z1, and a second m2, x2, y2, z2, m3, x3, y3, z3, and next so on as a mn, xn, yn, zn. Total mass of the body m is equal to m1 plus m2 and so on mn. Then rcm r vector cm is equal to m1 r1 vector plus m2 r2 vector plus m3 r3 vector plus so on upon m1 plus m2 plus m3 plus so on is equal to 1 upon m summations mi ri vector coordinate of center of mass. Coordinate of center of mass. x centimeter is equal to 1 upon m summations mi xi y centimeter is equal to 1 upon m summations mi y I, and z centimeter is equal to 1 upon m summations mi z I. Center of mass of continuous distributions of particles. R vector cm is equal to 1 upon m integrations r vector dm. Cm is equal to 1 upon m integrations x dm. Ycm is equal to 1 upon integrations ycm. Zcm is equal to 1 upon m integration z dm. X, y, z are the coordinate of the com of the dm mass. The center of mass after removal of a part of a body. Original mass capital M minus mass of removed part small m is equal to original mass capital M plus minus mass of removed part small m. The formula changes to xcm is equal to mx minus mx dash upon capital M minus small m. Ycm is equal to capital My minus my dash upon capital M minus m small m minus small m. Ycm is equal to mz minus mz upon capital M minus small m. Center of mass of some common objects. Body, shape of body, positions of center of mass. In body, uniform ring, center of mass, positions of center of mass, center of ring. Uniform disk, center of mass is center of mass at that point, center of disk. Uniform rod, center of mass at that point, center of rod. Solid sphere, hollow sphere, center of mass, center of a sphere, center of a sphere. Solid sphere, hollow sphere, center of mass at center of a sphere. Triangular plane lamina, point of intersections of the medians of the triangle, that is centroid. Plane lamina in the form of a square or rectangle or parallelogram. Center of mass at point of intersections of diagonals. Hollow solid cylinder. Middle point of the axis of cylinder. Middle point of axis of cylinder. Center of mass. Middle point of axis of cylinder. Half ring. Half ring. Center of mass at YCM is equal to 2r upon pi. Segment of a ring. Center of mass YCM is equal to r sin theta upon theta. Half disc plate is equal to YCM is equal to 4r upon 3 pi. Body, shape of body. Positions of center of mass. Hollow hemisphere. Positions YCM is equal to r upon 2. Sector of a disc plate. Center of mass YCM is equal to 2r sin theta upon 3 theta. Hollow hemisphere. Center of mass YCM is equal to r upon 2. Solid hemisphere. YCM is equal to 3r upon 8. 3r upon 8. Hollow cone is equal to center of mass YCM is equal to h upon 3. Solid cone. Shape of body. Positions of center of mass YCM is equal to h upon 4. Motions of center of mass. For a system of particles, velocity of center of mass VCM is equal to drCM. dr vector cm upon dt is equal to m1 v1 vector plus m2 v2 vector plus upon m1 plus m2 plus. Similarly, accelerations. A vector cm is equal to d upon dt. V vector cm is equal to m1 a1 vector plus m2 a2 vector plus upon m1 plus m2. Law of conservation of linear momentum. Linear momentum of a system of particle is equal to product of mass of system with velocity of its center of mass. From Newton's second law, F external is equal to d mv vector cm upon dt. If F external is equal to 0 vector m v vector cm is equal to constant. If no external force act on a system, the velocity of its center of mass remain constant. That is, velocity of center of mass is unaffected by internal forces.